Alrighty, in this video what we're going to do is we are going to take a look at integrating our client framework in with Unity, and we're going to see if we can actually get some real communication in with the server, and then we're going to see about getting this all deployed to our auto updater and our quote production unquote server, our staging server, however you want to call it. So basically, really the first step is I do want to go ahead and open up our server master systems namespace and take a look at the login system. Because if you recall, I put together a really basic little method here, the basic test. And I think that's going to just serve as how we're going to test the connection in with Photon and the client, and then have the client simply implement the basic client test method and have it printed out to the debug console. I'm not too concerned about doing anything crazy in this video. I just want to get the Unity API all working. I already have an idea about how I want to organize the code. So even from the start, we've always had this little Buzz MMO client Unity project right here. And the Buzz MMO client Unity project, it really only exists to allow us to take all of the code from our client console project, compile it, but use a different version of Photon. Because if you recall, we have our Photon 3 Unity 3D reference here in the Buzz MMO client Unity project, and that is going to be different than the Photon 3.net assembly. So we need to take the same code, and then we need to, that's the client console. I meant client. There we go. We need to take the same code in the client assembly and compile it, but we need to reference a different Photon assembly. And that's basically what the purpose of the client Unity project is going to be. It's going to be to carry over this code into Unity. For now, I'm going to be implementing the majority of the client code from within the Unity project itself. So the things like the Unity system factory and the Unity context and the player context, all that fun stuff, that's all going to be implemented from within the Unity assets folder itself, and not within the client Unity project here. I might change that in the future because once we start looking at sharing the client Unity project with the editor Unity project, as well as the client Unity project, once we start sharing code between the two, we might have to change how that works a little bit. But for now, having that code located inside of the Unity project itself will pretty much be the easiest way to go about doing this. So let's go ahead and get this started. So what I'm going to do is, remember, I'm saying that I want to carry over the code. So I don't want to copy these files from Buzz MMO Client into Client Unity. I want to link them. And I could link them, yeah, I'm just going to do this just really haphazardly. I'm not going to worry about putting them in the right folders, because that's just fairly irrelevant. So let's go ahead and do that. Let's right-click our Client Unity project, go to Add. Now, instead of hitting New Item, we're going to go to Existing Item. And then we're going to hop back into the source folder, locate buzzmo.client. And we're going to have to do this twice because we have two different folders we need to import files from. So we'll start with the infrastructure folder. And then I'm just going to click drag on all of these files. Now, instead of hitting Add right here, though, I'm going to click this little down arrow, and I'm going to say Add as Link. That way, they don't get copied over into the Client Unity project, and if we make a change in the client project, the changes will be reflected in the Client Unity project, which is exactly the behavior that we're looking for. I'm concerned... Oh, so we're going to get some errors because I didn't import log4net into the Buzz MMO Client Unity project. That's really easy to do. We're just going to right-click References, hit Add Reference, hit Browse. If you're not already in the lib folder, make sure you just back out into the root of the project, where the source control root is, jump into lib, Photon server, and grab log4net.dll. Hit Add, and then hit OK. Now, I could have just as easily added log4net as a NuGet package. I think I explained this in the last video, but I'm not going to do that because I don't want to run into log4net versioning conflicts, considering that Photon is going to use a particular version of Log4net, and I want to make sure that we use that. I'm not aware of any features in newer versions of Log4net that I'm interested in anyway, so it's been a pretty stable package for the many years it's been around. Okay, so now that we've done that, all our errors go away. That's good. The reason I was kind of concerned about those errors is because if I imported everything from infrastructure and I got an error somewhere, that could indicate that something from infrastructure references something from systems, which would break the encapsulation that I've been looking for with these namespaces. All right, so let's go ahead and go back to Client Unity, go to Add, Existing Item. And this time we're going to back out into the Buzz MMO client folder and locate the systems folder. And we're going to take all of these files and we're also going to add them as a link as well. And we get some errors because we don't have Castle. In this case, I am going to go ahead and import the NuGet package of castle.core into the Buzz MMO Client Unity project. So I'm going to right-click References, go to Manage NuGet Packages, and then I'm going to search for castle.core. And then I'm going to wait 2.5 years, and then I'll hit Install. Get that going, and as you see, all of our errors go away. Okay, so now our Client Unity project is pretty much done. I think it's time to go ahead and build this out and then open up Unity and start working on the actual client implementation. Before I do that, I do want to make sure that I'm actually dumping this into the appropriate folder, which I am. As you see in the Client Unity, the output path is specified as Unity Client Assets Assemblies. So by building this, it'll dump all the build artifacts into that folder, which will then be referenced and picked up by Unity. So now really all that's left to do is to hit Control-Shift-B to rebuild our solution. And by doing that, we should now have our client assemblies located within the Unity project itself. So before we jump into Unity, just a quick overview of what we're about to do. First of all, I do want to go ahead and inside of Unity, we're going to create a custom Log4net appender. I'll talk more about that in a moment. But the biggest thing that we're going to be doing is we're going to be needing to create our context class that contains all of our stuff. And it's going to kind of be considered to be the aggregate root of the entire system. And we're also going to need some sort of system factory that knows how to work with Unity. So we're going to be writing a Unity-specific system factory that doesn't rely on the activator class. All right, so let's go ahead and fire up Unity. I'm going to open a project here. I'm going to go ahead and I'm loading Unity 4.5, not 4.6 for now. We'll be moving to 4.6 when it comes out, or 5 actually when it comes out. Where is I think this is the right one. I am lost. You know what the easiest way to find a directory is in Visual Studio if you're ever curious on where your project actually lives on disk? Just right-click a project and say Open Folder in File Explorer. And that gives me that path. So coming back to the Open Existing Project, here's our path. And what I'm going to do is I'm going to go into Unity and open up Client. And then I'll hit Select Folder. And Unity should start up. I don't think I've started this project up for quite a while now. All right, so the first thing that we're going to want to do here is, oh, there's a new version. Does it do anything fun? Blah, blah, blah. Real-time shadows on every platform. Wait a sec, I am... What? Oh, it's a bug fix release. I don't care about that. I'll do that off screen sometime. That isn't now. Assemblies. Okay, so all of our assemblies are being imported. That's good. We have our BuzzMMO base. We have our... this file is probably a PDB file. I can verify that by hitting Show and Explore. Yeah, it's a PDB, a debugger symbol database. We don't care about that. We also have our Client Unity PDB, our Castle Core, that's a Castle Core XML, our Log4net, and our Photon 3 Unity 3D. So that's all we need. We also have our sample assets here for some reason. I don't know why that's there. I'm going to delete this folder because it's probably something I did off screen at some point and I forgot about it. Okay, next up we're going to open up our loader. And what I'm going to do here on the loader scene is I am going to go ahead and on the... I know that I added that test photon component to one of these guys, and I kind of want to get rid of that. It doesn't seem that I did. Okay, that's fine. So we have our test photon. Test photon is now no longer going to be used, so I'm just going to remove it. So basically make sure that you have no code anywhere inside of your assets. In addition, I'm going to preemptively switch over to using the .NET 2.0 full runtime, because I do believe there are going to be issues with Castle Core not working with the .NET 2.0 subset, but that's fine. I'm not particularly interested in using the subset anyway for this, at least for now. So what we're going to do is we're going to go to Edit, we're going to go to Project Settings, and we're going to select Editor. And that was totally not the right place that I wanted to go. So instead, what we're going to do, we're going to actually find the real place that we're going to go, and I believe that's Player, actually. And it is Player. Okay, so open up your Player Settings by going to that thing up there, and what we're going to do is go down to Other Settings, down here, and we're going to select .NET 2.0 as opposed to .NET 2.0 subset. So just make sure you do that on your PC, Mac, and Linux standalone builds. Okay, so now I'm going to, in the project folder, what I'm going to do is I'm going to hit create, hit folder, I'm going to create code. I'm just going to go ahead and create one C# file. For the majority of the C# files we're going to be creating within Visual Studio, but I need to add one C# file here for the folder to appear in Visual Studio once we open it up. And I'm just going to refer to this as Unity or game context. And this is going to be kind of the root object that represents all of the network connections to everything, and it'll be useful for things like giving a reference to our main camera or our player. And I'll talk about why I want to do the main camera in this as well here in a second. Let's go ahead and sync our mono-develop project. I like doing that manually as opposed to double-clicking a script file. And the reason is sometimes when you double-click a script file without preemptively manually syncing your mono-develop quote-unquote project, it doesn't open correctly. Okay, so we're going to go ahead and just fix the formatting on this, and we're going to nuke everything inside because we don't need any of that. And yeah, so before I go ahead and get started with writing out the game context, I think that's going to be like the last thing that we're going to do. The first thing I'm going to do is under the code namespace up here is I'm going to create a new namespace. I'm going to call it infrastructure, per usual. And then I'm going to go ahead and create a new class here. And I want to call this class Unity Log4Net Appender. And what this is going to do is this is going to, the way that we're going to configure it is we're going to have Log4Net output all of its stuff into the Unity console. And what that allows us to do is it allows us to use Log4Net inside of our client project and reference it however much we want. And then when we're in Unity, we will be able to see that output as opposed to printing to an actual log file, which we could do as well. We could combine the two if we wanted to. But for now, we're just going to print it out to the console because that'll be the easiest way of doing this. Now, to write a class that hooks into Log4Net, what you do is you make an appender. An appender is simply a class that implements the iAppender interface, which comes out of the log4net.appender namespace. And once we do that, we're going to go ahead and implement his members. And he really just has close, name, and do append. I'm going to reorder that a little bit. On close, I'm going to remove the implementation entirely. Name, I'm going to keep the name as a public getter and public setter because I could honestly care less of the appender. The real method that we have to worry about is do append. So basically, this class plugs into Log4Net, and it'll get notified whenever there's a new log message that needs to be printed out somewhere. And this do append method is what actually receives that invocation. So what we're going to do here is we're going to check the level of the logging event and then debug log out into, or debug warning or debug error out into the console. So I'm just going to say if logging event dot, and you'll see we have a bunch of really cool information here. We have our identity, our level, which is what we want, our logger name, our message, blah, 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 all this fun stuff. What we're worried about right here, though, is level. So I'm going to say if logging event.level equals level.error, or this is going to be fun. I'm just going to do this brute force. If logging event level equals error, or logging event level equals level.fatal. Is there any other error-y thing here? Yeah, so if it's an error or if it's fatal, then I'm going to say debug. Now this is going to import the Unity engine namespace up at the top of the file. And I'm going to say log error. And I'm going to pass in string.format placeholder placeholder. The first placeholder is going to be logging event dot logger name, and the second is going to be logger event dot rendered message. So rendered message is the thing that was actually the actual textual representation of the thing that is being logged. The logger name is going to be the class of that log. In fact, we could make this code a little bit cleaner. What I'm going to do is I'm going to take all of this, I'm just going to highlight it with my keyboard cursor, hit Control-Shift-R, and select extract variable. And I'm going to just leave this named message. Then I'm going to hit Control-Shift-Alt and hit the left arrow key to move this line of code outside of the if statement. Basically what I'm doing here is the message is going to be the same no matter what level we're working on. The only difference is going to be where it's printed out, or what method we use to print it out. So next up, I'm going to say else if logging event.level equals level.warn. Actually, I'm going to add critical to this list. If logging event.level equals level.critical. I don't need it to be comprehensive because I only use info, debug, error, and fatal, and warn. But, you know, we can add some more stuff in here if we want to. So if it's a warn, how about if it's a warn or if it's an alert? So if logging event dot level dot equals level dot alert. I could have probably just compared by integer values. I should have done that, but it's too late now. Log warning message, and then otherwise debug log message. So basically that's it. Straightforward, basic appender, prints out the log message. That probably took a lot longer to write than it should have, but there you go. So there's our log4net appender. I'm going to come back into game context now, and what I'm going to do is I'm going to do a couple things. First of all, I'm going to namespacify this class, which is a verb I just invented. So I'm going to say namespace assets.code. And if you recall, namespaces now work with Unity, with mono behaviors, and I want to make sure that we use or write code in the way that we should be writing code. So we're going to namespacify that class. Second thing I'm going to do is I'm going to say private static read-only ilog, which comes from the log4net namespace, log equals log manager dot get logger type of game context. Now what I'm going to do is I'm going to write my awake method. I'm going to say public void awake. And awake is going to, before we print out anything into our log, we're going to configure log4net to use our new log appender. And there's actually a convenient way to do this. If we do basic configurator, I love configurator, that's one of my favorite words, and that comes out of the log4net.config namespace, and do configure. Notice how we have a way to configure log4net without using an XML file, and we can specify a new instantiation of our appender. So that's exactly what I'm going to do here. I'm going to say, I'm going to pass in a new instantiation of Unity log4net appender. Then I'm going to say, now you guys don't have to do this, I'm just testing the logger for now. I will do error, bleh, log warn, bleh, log info, bleh. Next up, I am going to do one more thing here, just preemptively, because we're about to go attach our game context to our scene. I am going to say public camera main camera. Now, the reason I'm doing that is there is a feature that I'm really thinking about wanting to implement or have implemented, where we can have multiple clients connected through the same standalone at the same time using split screen. And the reason I'm thinking about this is for testing purposes, because then we could just hit the play button and have two players that are isolated from each other but running in the same process. And for that reason, I'm going to avoid referencing static classes as much as possible, even more than I typically will do. And part of that is going to be there can be multiple, in the future there may be multiple cameras, and I want the camera of a particular game context to be set by the game context itself. Now, again, this is just preemptive, me doing something preemptively based off a feature idea that I have, but I might as well do it. It's not going to hurt anything by doing it this way. Because remember, every actor, every system, and every bit of code that we're going to be writing will have access to this game context class. Now that we've done that, let's jump back into Unity. And what I'm going to do here is, I guess I'm just going to create a new empty game object. I'm going to go to the Create menu, and, see, I got so used to Unity 3.6. To create an empty game object in 3.5, we're going to go to the game object menu, and we're going to say Create Empty. And just for good measure, I'll set them to the origin, although that doesn't really matter. Then I'm going to say Add Component, and I'm going to type in Game Context. Once I add Game Context, I'm going to take the main camera, and I'm just going to associate it with the main camera property. Then let's hit play and see what we get in the console. Yep. So as you see, we indeed get our error, our warning, and our info. All right, so now that we've done that, let's go ahead and start working on our actual game context class and our systems, and actually get a connection going with the actual Photon instance. So in the infrastructure namespace, what I'm going to need to do is I'm going to need to create a system factory. So if we remember from our activator system factory, which is located in the client namespace infrastructure, or system, sorry, activator system factory, it's just a very generic way of instantiating classes. But when we instantiate systems inside of Unity, we're actually going to be instantiating them as mono behaviors. So not only are we going to have a system factory, we're also going to have an interface we can reference, and we're going to have a base type that implements iSystem base. So we're going to do all of that within the infrastructure namespace. I think what I am going to do here is I'm going to introduce another namespace called systems, and that's where all of our system-specific code is going to go into. This is another preemptive thing. I figure that in our infrastructure namespace, we're going to have a variety of different sort of things. We're going to have things for the actor RPC framework, and we're going to have things for, I don't know, cameras and split screens and all that fun stuff. So I'm just going to organize all of the system-related stuff into the systems namespace. I try not to go too crazy with namespaces anymore, because generally you can really make your entire project readable by creating too many namespaces. But in this case, I think that this is a good choice. We'll start off with creating an interface of iUnity system base. And he's going to have a one method, void set context, that takes in a game context, and then an object proxy. After that, we're going to create the Unity system base tick2. And we'll, of course, remove the tick2 from the actual class name. It'll have a T server and a T client. And it'll implement a couple of things. It'll first implement iSystem base, T server, T client. And it'll also implement iUnity system base. So if this is starting to look very familiar, it should. This is exactly what we did with our client console, like his iConsole system base and his console system base tick2. Same concept. Let's go ahead and generate all of our members. I'm going to move dispose down here. Let's do our server. I really don't like these properties. I'm sorry. It was possibly a design mistake to have these properties exposed like this, but what can you do? Okay, Oh yeah, before I forget, Unity system base is actually going to A, the abstract, and B, he's going to inherit from mono behavior, which of course comes from the Unity engine namespace. So make sure, this is important, make sure that you have made this class inherit from mono behavior. Okay, now that we've done that, let's go ahead and add our fields. I'm going to say protected tserver proxy, and I'm going to say protected game context. And for now, those are going to be our primary two things right there. Set context, I'm going to turn this into an explicit implementation. So I'm going to remove its accessibility modifier and then qualify which interface we're implementing this from, which is in this case is going to be iUnity system base dot, like that. The implementation of set context is trivial. We're just going to say context equals context and proxy equals cast to tserver proxy. The dispose method, what I'm going to do with the dispose method is, what am I going to do with the dispose method? I think I'm going to handle the dispose method. Actually, I think the dispose method is going to have to be responsible for destroying this game object, or destroying this mono behavior. So what I'm going to do here is I'm going to go ahead and create a protected virtual void on dispose, or how about on destroy? And, it's virtual, not abstract, so I have to give it an implementation. What dispose is going to do is it's going to say on destroy, which will give the implementing type or the inheriting type a chance to clean up. And then it's just going to say destroy this. Now, it's important that we're not destroying the game object, because what I'm going to have is I'm going to have a game object that contains all of the systems. So we only want to destroy the actual mono behavior that this system represents. So that's why we're saying destroy this. Okay, before we move on to our actual... Now, this is it, pretty much. There's not a whole lot else we have to do here. But I do need an attribute. I need an attribute so that I can annotate what should be considered a system. So inside the system's namespace, I'm going to create a new class, and I'm going to call this Unity System Attribute. And he's going to inherit from attribute. And he's going to have an attribute usage of attribute target class. And that's it. We're just going to use this attribute to select on the types that we want. Okay, so the big one here isn't these three classes. It's going to be the Unity System Factory. So the Unity System Factory is going to be basically the most important type that we're going to be dealing with here. And what I'm going to do is I'm not going to make this a mono behavior because there's really no reason for it to be one. So I'm going to go ahead and give it a constructor. And in its constructor, it's going to take in a game context. And we're going to alias that out into a private read-only field, underscore context. We also have to make this class, of course, we have to make this class implement the iSystem Factory interface, which comes from the Buzz MMO client systems namespace. And then, of course, we're going to have to implement its only member, which is create system. So I just generated the stub for that right there. So, yeah. Actually, I completely forgot about how I did this. I'm going to go ahead and blah, blah, blah. Okay, I do actually need a reference to the system type registry, unfortunately. I forgot about that. So in addition to getting the game context, I'm going to take in a system type registry. And then I'll alias that into a field. We use the registry to know how to get from an interface type, a client interface type, to a concrete type. And we need to know what concrete types we have so we can add them to a game object. Furthermore, before we go ahead and actually implement the create system method, we do need to go about creating a game object that's going to house all of our systems. So what I'm going to do is I'm going to create a field, and it's going to be underscore systems container game object, and I'm going to say new game object, which of course will import the Unity engine namespace, and I'm going to give it a name of systems. In addition, I'm going to say underscore systems container game object. I'm going to say dot transform dot parent equals context dot transform. And that'll just parent it in the hierarchy to our game context, and it'll make things a little bit cleaner in the hierarchy. Now, of course, the last thing we need to do is actually implement this field. Easiest way to do that is going to be to hit Alt-Enter, Enter, and make sure it's read-only, because there's no reason for it to not be read-only. So make sure you go ahead and actually add your private read-only game object field for the systems container game object. Okay, with that all out of the way, we can create our system. So whenever the network layer tells us to create a system, this is what we're going to do. We're first going to get a registered system out of our registry. So I'm going to say get system from client interface type, passing in interface type. Then we need to actually instantiate the system. So I'm going to say var system instance equals cast to iUnity system base. And then I'm going to say underscore systems container game object add component. And I'm going to pass in registered system.concrete type. So remember, the registered system is how we're going to know what concrete type this system is mapped to. Next up, we need to instantiate our proxy. So I'm going to say var proxy equals proxy factory. Remember the proxy factory that comes in as a parameter here? And I'm going to pass in registered system.server interface type. Then I'm going to say system instance dot set context, passing in the game context and the server proxy. Then I'm going to set the concrete type to equal registered system.concrete type, and I'm simply going to return cast to iSystem base system instance. And that's it. That's our Unity system factory. So it's just responsible for creating those game objects, and the cool thing about this is our systems can actually be game objects, so they can do things like handle update methods and other Unity-y type things. All right, with that all out of the way, we can go ahead and finally write our game context. So our game context is going to have a handful of public properties on him that we're going to need. In this case, actually, I think we're only going to have one. Actually, we do need to implement a player module, unfortunately. So how do I want to handle that? I could put it in infrastructure module. No, I'm just going to add it to the code namespace. Okay, so I do want to go ahead and write the player module. If you guys recall, the player module is what's going to be responsible for doing player-y type things that don't go into the system implementation. For example, it's going to have to initialize itself as a player. It's also, in the future, could do multiple things like handle authentication and other fun stuff like that. But for now, it's just going to be really simple. All the player module is going to do is it's going to be responsible for telling the server that it's a player. So I'm going to make a player module. The player module is going to implement iEventReader module out of the client infrastructure namespace. And that's going to require that it returns registrations. But before we do that, I do want to go ahead and create a constructor. And the constructor, just like our console player module, is going to take in a game context and an iClient transport. And these are both going to be aliased into local read-only fields, or private read-only fields. As far as our get registrations, we're simply going to yield break, because in this case, we're not going to actually be doing any event reading. But before I forget, of course, jump back into the constructor. We're going to do transport.addEventReader this, so that in the future, if we ever want to subscribe to any particular event from the server, we can do so without, running into issues. Finally, we're just going to need one public method, and it's just going to be initPlayer. And for now, it's going to be identical to what we have on the console. So we're going to say var parameters equals new dictionary of type byte and object. We're going to say parameters cast a byte operation parameter coming from base infrastructure. Dot context type equals context type dot player. And then we're going to say transport dot send operation, passing in the operation code of init context, and then the parameters. And we're not going to worry about having a return on that. And that's it. That is our player module. Okay, so now we can finally come back and implement our game context. So our game context is going to have two public fields. We're going to have a public player module. We're also going to have a public system, or not a system type registry. We're going to have a public client systems coming out of the BuzzMMO client systems namespace. And we're going to call this systems. And I think that's going to do it as far as public properties go here. But we do need to go ahead and add some private fields. And I'm just going to do that preemptively up here so that we don't have to jump around the file a whole lot. So above these properties, I'm going to say private iClient transport. I'm also going to say private system type registry. Finally, the last thing I'm going to do while we're up here is on the game context, I'm also going to implement iClient transport listener. And I'm going to implement his one method of transport status changed. All right, that should be it as far as jumping around for now, hopefully. Let's go ahead and remove those log messages. And then I'm going to delineate everything by sections. So the first thing I'm going to do is I'm going to say create systems. And I'm just going to run this down line by line and create every individual component manually. So first I'm going to say type registry equals new system type registry. I'm going to say system factory equals new Unity system factory, which of course comes from the infrastructure namespace, or infrastructure systems namespace. Passing in ourselves and the type registry as per constructor arguments. I'm going to say systems component map equals new component map. I'm going to say systems operation writer. Oh, I will need to instantiate my transport, won't I? We'll do that momentarily. Equals new systems operation writer, passing in a serializer, which we'll also need as well. So I'm going to say serializer and transport. So I am going to go ahead and just leave that as a not implemented field for the moment. We'll implement the field in a momentarily here. And then I'm going to say systems equals new client systems, passing in systems component map, system factory, and systems operation writer. And then finally, I'm going to say underscore transport dot add event reader, new systems event reader, passing in our serializer and our systems. Then we're also going to have a create player module. And this is simply going to say player module equals new player module, passing in ourselves and our transport. Now, unfortunately, I overlooked two things here. I need to actually instantiate the transport before we create the systems, and I also need to create a serializer. So let's start with the serializer. Up here at the top, I'm going to say private iSerializer, serializer. And then at the top of the method, after we configure our log4net, I'm going to say underscore serializer equals new simple serializer. Then I'm going to say underscore transport equals new Photon client transport, so that that's instantiated before we instantiate our systems. All right, moving along, let's implement our start method. I'm going to say public void start, which will be invoked after awake. I'm going to say underscore transport dot, or actually no, I don't want the type of transport to be iClient transport. I want it to be a Photon client transport. We need to actually have access to the Photon specific methods in order to actually handle them within this class. So the start method is going to say transport.connect, and we're going to connect to an address in an application. What I'm going to do here is I'm just going to cheat. I'm going to say if Unity editor else end. If Unity editor connect to 127.0.0.1 and then what's the port? I always forget the port. The port is 5055. And the application name is buzzmmo.server.master. Then I'm going to copy this line and dump it into the else. And I'm going to change the address to whatever address our... Well, now I forget. Let me go ahead and pop open source tree for a second, and I'm going to look... Remember how I deleted that test thing before? That test script actually had the appropriate address for the staging server, but I forgot it, and then I deleted it. So I'm going to have to go and dig through source control to find you. It's 192.168.2.138. That's going to be different because we're not going to worry about that right now. In the next video, we'll actually worry about getting this hooked up to the continuous integration server. Okay, so start is just going to connect the transport. Then I'm going to say public void update. Update is going to say transport.service. And then I'm going to say public void on application quit. I'm going to say transport.disconnect. And while you guys look at that code, I'm going to verify that on application quit is indeed the proper name. And it is. On application quit is a message that's sent to all game objects before the application actually ends. So that gives us a chance to actually disconnect from the server. Now that we've done that, we have one last thing. When we actually do manage to establish a connection to the server, I want our player module to initialize. So I'm going to say if status equals connected. I'm going to say if status does not equal connected, return, otherwise player module dot init player. And that's it. That is our game context. This is the root object into the entire system. This is where we're going to be putting our all our fun stuff. I am, of course, forgetting one actual very important thing, because of course I am. It wouldn't be me if I wasn't forgetting something very important, and that is I never actually registered our actual systems, and I never created a concrete implementation of the login system. So to fix that, what I'm going to do is in the start method, before we connect, I'm going to say underscore type registry dot scan assembly type of game context dot assembly, and then passing in a type of Unity system attribute. Actually, I think I can go ahead and do this scan. I'm not going to do it in start. I'm going to do it right after we instantiate the type registry. I think that makes a little bit more sense, and it cleans up the code a tad. So I just moved this line of code up here. It really wouldn't make a difference where it is, as long as it appears after we actually instantiate that object. All right, now let's go ahead and implement our login system. So I'm going to create a new folder, and I'm going to call this namespace systems, and I'm going to create a new login system. Login system is going to inherit from Unity system base, passing in an I login system server and I login system client as generic parameters, and it's going to also implement I login system client. Let's go ahead and implement its members. It only has one basic client test, and then I'm going to say debug.log client test count, and then I'm going to say proxy.basic test count. I believe that's the implementation that we had on our client. Oh, it'll say count plus 1. And of course, remember, again, with our login system, we have access to our context. And because we have access to our context, we have access to our things like our systems, where we can do cross-communication between systems and all that fun stuff. All right, now that we've done that, I think we're about ready to go ahead and get Photon Control running. So I'm going to do that. I'm also going to go ahead and open its, or I'm going to say default, start as application. And then I'm going to say, I'm going to go ahead and open my log fusion. I'll close all my logs. Then I'm going to go ahead and locate Photon. I can't remember where I put it. I could have swore I put a bookmark somewhere in there for it. Actually, isn't there a right click? Here we go. Explore working path. And then I'm going to grab the log, and I'm going to go ahead and get these 2 logs, dump them over into Log Fusion. I'm also going to back out into the log folder underneath Photon directly and get the master server. Clear everything out. All right, let's jump into Unity. So this game object, I'm actually really not a big fan of this game object that contains the game object being named game object. So I'm going to call this game context instead. All right, let's go ahead and hit play and see what happens. Status changed, connect. Well, I guess that's good. But we seem to have a problem somewhere. Debug log status. Ooh, I'm stupid. When we connected, I never actually added ourselves as a listener to the transport, so this object never got notified when our transport status changed. That's easy to fix. After we instantiate our transport, I'm going to say transport.addListener this, so that we're now getting notified of when the transport gets updated. Now that we've done that, let's go back to Unity and hit play. And we get a couple errors. So the first error we get is, the login system. I forgot to annotate it with the Unity system attribute. So I'm going to annotate it with Unity system. Again, remember, if I didn't annotate it with this, then it's not going to be scanned by the type registry. Let's go back to Unity again. Hit play. And look at that. What's cool about this is this proves that it's working not only from the server to the client, but the client to the server. We can also inspect our game context class and see that our systems is there, and see that login system is there as well. In fact, we could also do something more interesting. On the server, so I'm going to go to Server Master, Systems, Login System. I'm going to say, if count is smaller than 100, invoke the basic client test. Otherwise, what I want to do is I want to say context.systems.destroy login system. So let's see if we can actually destroy the login system and have the component removed from Unity. Of course, we made a change to the server, so we're going to have to hit F6 or Control-Shift-B to rebuild it. And we're going to have to wait to see it showing up here on our logs. It seems to have unloaded good. Going back into Unity, let's hit play. So we get our client tests, and we come back to Systems, and notice how it's empty. I don't know if you guys saw it. Let me see if I can see. Login system, login system, login system, dead. In fact, if debug log wasn't so slow, Let me take out the debug log out of our client system. Hit play. It should almost immediately go away. Yeah, it pretty much does immediately after it's connected. Like a second. Either way, that about wraps everything up, honestly. We have Unity. I'm going to come up with a better way to handle configuration stuff, because that's pretty ugly right there, and we'll handle that in the next video. But yeah, things are really looking good now. We have our game context, which is kind of our root to the entire system, and we have our individual systems that we can implement with the RPC. Again, really, all you have to do to implement a system is you need two interfaces that are shared. So, for example, in here, we have our login system. We need two interfaces. We need one class on the server, the login system here. So you can see that right there. And then we need one class on the client, the corresponding system, and that's it. And that's really, really the goal of everything we've done so far. Now that I think about it, I really don't like that attribute. Because my understanding is that the system type registry doesn't need an attribute, does it? System... Where's their system type registry? There it is. Let's see here. Yeah, it's just going to look to see if something implements iSystem base. I'm going to remove this attribute. I don't want to have to keep on remembering to add the Unity system attribute to all of our Unity system classes. The only reason I did that for the testing class was because we would have so many conflicts otherwise. So I'm going to take off this attribute here. I'm going to open up the infrastructure systems namespace. I'm going to delete the attribute from there. And then I'm going to open up the game context class. And instead of passing in the system attribute, we're going to pass in nothing like that. So we're just going to scan assembly, and we're going to scan for every single thing that implements the iSystem base interface, and then we'll register that with our type registry. Let's make sure things work. Going back into Unity, hit play, and everything seems to be working just fine. But yeah, so basically what we've accomplished is the ability for the server to at any point instantiate a particular type on the client and then communicate with it in a very transparent way using dynamic proxies. So there's a lot more stuff we need to do, but things are looking like we'll be able to actually write some game logic here pretty soon. Either way though, I think we'll go ahead and see you guys in the next video.